Hello, welcome to this lesson of our study of differential equations. Okay, so like I said in our previous lesson, I said that in this lesson we'll go through how to solve exact differential equations. So solving exact differential equation is what we're coming to do in this lesson. Okay, so we pick two examples, then I give you one to go and try on your own. Okay, all right. So if you have not subscribed to my channel, kindly subscribe, okay, so that you can support the channel as well. If you have subscribed, like my video, and also leave your comments in my comment section. Okay, all right. So if you have an exact differential equation, we said that in our last discussion that and you have exact differential equation, then your m here, which is your m of xy, is always equal to there's this function. Okay, for exact differential equation, I'm repeating that again, there's a solution. The solution is this, okay, some f of xy that each total derivative is given by this whole equation as a differential equation. Okay, so if I want to solve this, then I know that when it is exact, m is equal to del f del x. I mean, when you pick that solution, the function we don't know, and differentiate with respect to x, you get m. And then when you pick it and also differentiate with respect to y, this time we get n. Okay, so if you want to solve it, this is very simple. Okay, I have del f del y equals some n. Okay, when differentiate with respect to y, you get this. So it means that my del f, I'm using method of separation here, is the same as n del y. Okay, this means I can integrate both sides. Okay, when I integrate the left side with respect to f, I have f of xy. That is our solution, and it should be called the integral of n with respect to y. I hope you get this. So if I pick the n, that one too has to do with different integrating m. Okay, if I pick the m, that one too has to do with integrating m with respect to what, x. I hope you get this. So this is very simple. In solving exact differential equation, that's the easiest. It is one of the differential equations you can get and solve. Okay, so after everything, and you'll be able to find your f of xy, then the solution is f of xy equals c as your answer. Okay, so f of xy is actually the function that is equal to a constant, and its total derivative give you this whole differential equation. Okay, I hope you get this. So let's pick an example and try our hands on that. Now solve the differential equation 1 minus 2xy dx plus 4y cubed minus s squared dy. Now in our previous lesson we just showed that, or we were able to show that this is actually exact differential equation. Okay, so like I always say, I'm always building upon the lessons we've done. Okay, so if you want to cope with us, if you want to go by us, or if you really understand this video, I don't have any problem with you. But if you have any problem with exactness and the rest, you can check out on my other videos in my playlist of first order ODE. Okay, so I have a playlist titled first order ordinary differential equation, so you can check that one. Okay, all right. So here m is equal to what? 1 minus 2xy. Okay, and our n is equal to 4y cubed minus s squared. Okay, and these are m and n. Okay, so we said that m is the same as, okay, let me go by it step by step. M is the same as del f, there's a function like that, del x, and then n is also equal to del f del y. So what we'll do here is that we have to, when you see that the function is both functions are very easy to integrate, my advice to you is that just integrate them. Okay, try to integrate both of them, and then after that you will see what I'm coming to do here. After that you pick your solution, very simple like that. Okay, so f of xy here with the first m. Okay, if I pick m, f of xy is equal to the integral of m with respect to what we just said, this with respect to x, and that is equal to integral of 1 minus 2xy. Okay, let me erase that, 2xy then dx. But remember that m is this. Okay, and then f of xy is a function of both x and y. Okay, but we are integrating m with respect to only x. So when I integrate 1 with respect to x, I get x minus, when I integrate this side, I'm integrating with respect to x, so I have to integrate only the x side. Okay, I have to integrate only the x, and that will give me s squared over 2, but I have minus 2 in front already, so I'll have something like s. Let me write it. Okay, but I have minus 2, then I integrate the s, I'll get s squared over 2. Okay, multiplying y, okay, and there should be another constant. There is always a constant of integration for indefinite integrals, okay, and this constant is supposed to be a function of y, because look, m is equal to differentiating f only with respect to x, meaning that if f was having something like, if f was equal to, let's say, x, okay, minus s squared y plus another, let's say, y, when I differentiate this with respect to with respect to x, it means this side will go to 0, because in that case y is actually a constant, and that is a function of y only. So it means that after doing an integration for a function that is dependent on two variables, the constant is always the function of the other variable, okay. So this constant should be k of some y, okay. And indeed, if I differentiate this, I'll get back my m. I hope you get this. So it means that using the m, I have f of xy being equal to x minus s squared y, then plus the constant k of y. Now try to differentiate this with respect to x, and you get your m back, okay, meaning that always the constant k of y is a constant, okay, in terms of saying that the function is, we are doing the integration with respect to x, then the k of y should be a constant, okay. So the other case is that f of xy is also equal to integrating n with respect to y. I hope you get the point. So this is equal to integrating n, and n is giving us 4y cubed minus s squared, okay, minus s squared, then dy, okay, and we are integrating with respect to only y, so it means that the constant should be a function of x, okay. So always check these. So I have 4, then when I integrate y cube, I have y to the power 4 over 4, okay, and minus s squared y, because this x is a constant in terms of y. We are considering it as a function of only y, so it means if I integrate s squared with respect to y, the s squared is now a constant, so I just multiply y to it. I hope you know how to integrate a constant. When you have a constant, let's say c, and you integrate c with respect to s, you have cx. So here the s squared in terms of dy is a constant, so when you integrate s squared with respect to y, you get x squared y, okay. I'm explaining things here, and I hope you get them, okay. Then plus another constant. You are doing everything with respect to y, so it means the constant should be a function of x, and p of x. This means that I have y to the power 4 minus s squared y plus some p of xy, okay. Let me call this our first equation and call this our second equation. They are both solutions of the functions, okay, or the function. Let me put it that way. The function f of s y has these two solutions. So look through the first equation. What do you see? You see x, okay. This is only a function of x, and I have a function of both x and y, and this is a function of only y, which I don't know. Let's look through the other one. This one has a function of only y. This is a function of both x and y, and this is a function of only x. Look through the two equations, you realize that this particular one, let me mark it with the yellow pen, okay, this particular term is found here and is also found here, meaning the rest of the terms are the individual constants. Now I realize that this k of y should be a function of only y, so it means when I come to the second one, this should be that function. So k of xy or k of y should be equal to y to the power 4, okay. And also if I look at the first equation, I realize that there's an x only here, and I'm looking for some function which is only x, meaning p of x is actually equal to that x there. So now we've been able to deduce or find our constants k of y and then p of x. So we pick any of the function we want and put those constants there, okay. So you can pick the first one. Whatever constant you pick and put it there, the solution should be the same. So if I'm using the first equation, f of xy, or the first equation, f of xy is equal to some x minus s squared y plus some k of y, and we are saying k of y is what? Y to the power 4. So let me go and put it there, y to the power 4, and this is my solution. Or if I use the second one, we are saying that f of xy should be equal to y to the power 4 minus s squared y plus some p of s. And you are saying that p of s is actually equal to the one here, which is the x. So it means I have x. Now compare these two equations, or these two solutions. They are the same, right? So I have plus y to the power 4. I have plus, this is also positive, so the same thing. I have plus x. I have positive x here. This is also the same thing. And I have minus here. I have minus. So it means the alternative way is that you can also say that after that you add the two equations, but the ones that appear in both cases, you write one of them and then you throw away the constants. Okay, this is what I mean. If you were supposed to add the two equations, I have f of xy. I'm using my time to explain this, and in the next question I'll just go through it straight away. Okay, the first one has this x minus s squared y plus some k of y. Okay, and the second one has an equation of this form: y to the power 4 minus s squared y plus some p of x. So what you do is, in order to do away with your constants and write your final solution, f of xy should be equal to the sum of these equations. Okay, but when I see this here and I also see this here, I write one of them. Okay, but the intuitive idea is what I just explained before this. So I add x to this, so I have x plus y to the power 4 then minus s squared y. It's appearing on both sides, so I just write one of them, and then I just throw away these to get your solution. That's what you do, simply like that. You throw away the constants, you add the two solutions. Make sure that the ones that are appearing in both equations, you write one only. You write only one. Okay, I hope you understood this. And so your solution, we are saying that our solution is equal to f of xy is equal to c. So it means the solution to the differential equation is s plus y to the power 4 minus s squared y, okay, is equal to some c, some constant c, and this is your solution. Now you realize that this differential equation is as well as a homogeneous. No, this is not homogeneous. I'm really sorry about this. This is not homogeneous, and this does not contain any constant coefficients. So I really don't know if you can use any of the methods to solve. But since it's exact, we are cool with that, and we just go like that. Okay. Now let's go through the second one. The second question, I'll really speed up this time. Okay, so I want to finish early so that we just go through. I'll give you an assignment for you to go and do. Okay. So with the second one, we have dy dx equals dy dx is equal to 12x. Okay, let me write it well. 12s plus 7y, okay, over 6y minus 7x. And the question continuing to ask us to find a particular solution when y equals 1 then x equal to 1. Okay, so we after that we should find a particular solution. Now to solve this, I have to just cross multiply by I hope when I do cross multiplication you understand what I'm trying to do. 6y minus 7x, then multiplying the y, okay, and this should be equal to 12x plus 7y multiplying the x. I hope you understood this. This is very simple, right? So this implies that if I pick this one and send it to the other side of the equation, okay, I'll get 0 equals something. Okay, so let me rewrite it. I have this x plus 7y dx minus 6y minus 7x dy. Okay, let me pick the whole of this and come and write it here. I have 12x, okay, 12x plus 7y, then the x should be equal to plus, okay, I'm multiplying through this minus, and I'll have minus 6. Well, you let me write it, and at the end I'll come and write it back. I don't want to confuse you, okay? Minus 6y minus 7x dy should be equal to 0. Okay, this is equal to 0. And I realize that when the negative of this one goes through that, okay, I'll have negative here and I'll have plus here, and then here will be plus. I hope you understand this. So in effect, I have 12x plus 7y dx plus 7x minus 6y dy equals 0. So this is very simple, just rearranging it, and we had that. Okay, so let's quickly write it back and then compare and get our m and then our n. Okay, so I have 12x plus 7y dx dx the x, then plus 7x minus 6y dy equals 0. So quickly, m is equal to 12x plus 7y, and then our n is equal to 7x minus 6y. It means that I have to check for my exactness. Del m del y, okay, should be equal to 7, and del n del x should be equal to 7. And hence, since these two are the same, we have an exact differential equation, okay? So let me clean that quickly. Once we have that, it means I should continue and then use my exact method, okay? So to use the exact method, we said that there's a function. Since this is exact, there's a function f of xy which is equal to the integral of m with respect to x, or the integral of n with respect to y, and this is equal to the integral of 12x plus 7y then the x, and this will give me 12s squared over 2, and that will be 6s squared, okay? I'm doing it straight, plus 7xy. I explained why there should be 7x, because 7y here is all constant, so when I differentiate I get 7xy, or 7y times x, then plus a certain constant, say k of y, okay? And then when you pick the n, that same f of xy is the same as integral of n with respect to y, and we are saying that this is equal to integral of 7x minus 6y dy, okay? And this will give me 7xy minus 6y squared over 2, which is 3y squared, then plus some constant p of x. I explained why the constant should be a function, so should be functions, okay? I hope you understood it in the last example, or in the first example you solved. And I said that once you have these, the alternative way is that you just sum these functions, okay? This is the first solution we have. We have this first solution to be this, and the second solution is giving us 7xy minus y, 3y squared plus p of x. And I said that in order to get your f of xy, the total f of xy, okay, should be equal to summing the two solutions you had, okay? And this should be equal to 6s squared plus 7xy plus the whole of this. But I realize that 7xy is appearing in both, so you just keep one of them, okay? Don't sum the two and write 14xy, no, just write one of them, and then you write the remaining function in the other one, okay? And then you throw away the constants, okay? That is the constant function. So this will be equal to 6s squared plus 7xy minus 3y squared, and that is all. You throw away the constants, okay? Sometimes too, you don't get it easier like this, okay? Like I'm doing, you really don't get it easier. You should go and then look for your constants, and I think I'll have to show you the way in case you don't get these constants easier like that, okay? So this is that, or like I said in the other one, I said that you can compare these ones and realize that this function is this one is the same as the one we've gotten down here. 7xy is here, 7xy is here. It means that when I come to the first equation, wherever I see k of y is the same as the function with respect to only y here, and I can put it there and then say that that's my f of xy. Or when I come to this p of x, I go to the other solution and realize that 6s squared is the only x function here, so I come and put 6s squared here, and that is it. So after putting your constants in each of the equations you had for the function, you realize that the function is the same for both, okay? Or the alternative way is just summing them, writing one of the repeated functions or repeated terms and throwing away the constants, okay? If only that is possible there, then you do that and go. And this means that our solution, which is given by f of xy is equal to c, is that 6s squared plus 7xy minus 3y squared should be equal to c. This is the general solution. The question asks us to find the particular solution when x equals 1, y is equal to 1. This means that I put 1 in place of x and y at the same time, okay? So I have this just to find my c. And that when you simplify this, you have c equals 10, right? So this simply means that my function or my particular solution is that 6s squared plus 7xy minus 3y squared should be equal to some 10, okay? This is a solution. Now I realize that in this particular question, After simplifying everything, you get a homogeneous one. This is a homogeneous differential equation. So you can also apply the homogeneous method and see if you'll be able to get the same thing. Okay, so like I said that after getting your functions like this, okay, how do you go about if you don't see the constant straight away like that? Okay, so in the first case we had the function to be using the m. We had 6x squared. Okay, we had 6x squared plus 7xy plus k of y. Okay, and you can only find y when you try to differentiate f with respect to y. Okay, let me differentiate f with respect to y and see, and this will give me, here will give me 0 plus here will give me 7x plus k prime of y. Okay, but what is del f del y? We said that del f del y is the same as n. Okay, so you come and put n there. So I have n is equal to what? 7x minus 6y, and this should be equal to 7x plus k prime of y. Okay, that's the main or the right way of finding your constants. Okay, so you pick one of the, you first solve for m, you don't do for n. When that is why I said that when you see that the two functions, the m and n, they are easier to integrate, you pick the both of them, integrate both of them with respect to their respective variables, then you sum them and then throw away the constants, write only one of the repeated terms. But if they are not, or if one of the functions, I mean n or n, is very difficult to integrate, pick the one that is easier to integrate and use this method to find the constant, and that will be all. Okay, so when I pick this 7x, I send it to the other side of the equation. I have 7x here minus 7x minus 6y is equal to k prime of y. Okay, and this will cancel this. So I have k prime of y being equal to minus 6y. Okay, so if I want y, then I have to integrate k prime with respect to y. So when I integrate k prime, okay, this k prime is the same as the k dy. Okay, k prime of y is the same as that. So let me first write this before I integrate. Okay, so the k prime is the same as the k dy, and this is equal to minus 6y, and the k will be equal to minus 6y dy. So I integrate both sides. I have k of y being equal to minus 3y squared. I hope you understood this. This minus 3y squared. So I'll go back and pick the solution we had for the first one. Okay, this one. Then we put k of y there. So we have our solution to be f of xy being equal to 6x squared plus 7xy. Then my k of y is minus 3y squared. And this is the solution. I hope you remember that this is the same solution we had. So this is the actual way of doing it. So kindly bear with me if you are not able to integrate both of them. This is how you go about it. You pick the m, integrate the m with respect to x, and realize that the constant of integration is some k of y. Then to find your k of y, try to differentiate the whole function with respect to y again. And in our first discussion with the previous lesson we had on the exact differential equation, we said that del f del y is equal to n. So you put your n there and try to simplify it and integrate back to get your k. I hope you understood this. Okay, so that you not be facing problems when you meet functions you can't integrate both, but maybe one of them is the easiest way for you to integrate. Then you apply what I said. Okay, so there's your trial work to do. You go and try these for me. You try to solve this. Dy dx is equal to 2xy plus 6x over 6y cubed minus x squared. Okay, and the answer to this question is x squared y, okay, plus 3x squared minus y to the power 4 equals some constant c, and find a particular solution when y equals 1 and x is equal to 1, and that one too is s squared y plus 3s squared minus y to the power 4 equals 3. I hope you understood this. So this is your task to do. And the second one is you're supposed to solve this y cos x plus 2x e to the y e to the power y, then the x, or no, there's no dx here, then plus sine x plus s squared e to the y plus 2, then dy dx, okay, equals 0. So you're supposed to solve this, and the answer is y sine of x plus s squared e to the y plus 2y equals some constant c. Okay, so always remember this. Now with this particular question, I think you are supposed to use the method I said. Okay, but if you can integrate, of course you can integrate everything with respect to y, all of them with respect to their respective variables, then I don't have any problem with you. Okay, so now this one, I have a third one which says that dy dx, okay, dy dx should be equal to y into y squared minus 3s squared plus 1 over x into s squared minus 3y squared minus 1. And you are supposed to solve this. The answer is giving us xy into s squared minus y squared minus 1 equals c. This is a general solution. So can you go through them? And like I always say, like my video and also comment. Let me know if you're able to solve it, so that I see that we are all growing together, we are all understanding mathematics together. Okay, so give me a comment in the comment section for me to know that you're able to solve it. And if you are not able to solve it, I'll give you a hint on how to solve it. Okay, thank you, and don't forget to subscribe to my channel if you have not subscribed. See you next time.